Hello class, welcome back to another section for intensive calculus course. Still on application use of differentiation. In this class, we're going to consider maximum and minimum values. Under this, we will look at the local and the global or absolute minimum and maximum. Then, we look at the Fermat's theorem and solve an example on it. Watch this video to the end so that you understand every part of the video. Don't forget to like and subscribe, also share to your friends if you're new here, and if you want to join the class and understand the progress of the course. Maximum and minimum values. What is it about? If I have a graph and I draw a curve, a curve look wavy. This is because we have something we call the critical values, the turning point or the stationary point, where there is a change in direction. It will rise to a certain level, then it will stop, change direction. So that is what we call the critical values. So in this calculus course, everything we do is progressive. Based on what we did in our previous video, we're going to apply as we proceed. So you realize that in this curve, I have one stationary point here, I have another stationary point here, I have another one here, I have another one here, I have another one here. Some stationary points point upwards and some are down. And you realize that some stationary points are above others. So these changes or these differences gives the various classification as local and global, or which is sometimes called absolute maximum and minimum. So if you have this, which is a critical point facing up like this, on an increasing graph like this, we see it is a maximum value. It gives a maximum value. But if it's down like this, that is below the rest of its neighborhoods, then we say that it is a minimum value. So this is a minimum critical point C2, this C1. When you come here, you get a maximum critical point C3. Then at this point, you get a minimum critical point C4. Then finally, a maximum critical point C5. What do we mean by local? What do we mean by global or absolute? When you say something is local, meaning among your neighborhoods, among your peers. So if you realize this C that you have here, it's only above its peers, its domain, but it's not above the other critical points I have here. So I will say that this is a local maximum. When I come here, you realize that this is below its neighborhoods or its peers around it, but it's not below the entire graph. So this is said to be a local minimum. You are minimum to your own people. But when you come here, likewise, you're going to have a critical point which is a maximum. But it is not above the entire population, but rather above its neighborhood. Therefore, we see it is a maximum value, but a local maximum. When I come here, you realize that this C4, this critical point, is below every minimum point here, and it is the peak where you can get down. I mean, it's a break here. So therefore, I will say that this will be my global minimum. Then this part is also a maximum value, but it is the uppest, or it is the farthest the graph can go. So it is above the entire population. So you say global or absolute maximum. This scenario should give you the best understanding of global and local minimum and maximum. Fermat's theorem. What do you say Fermat's theorem? Fermat's theorem is somehow a common sense statement. What it's saying is, if f has a local maximum or minimum at a certain point, then that point is a critical point. Yes, it's true. A point can be a maximum and minimum provided that part is a stationary point or there is a turning. So Fermat is just emphasizing the fact that if I have C1, C2, C3, which are my turning points, giving me the maximum and the minimum values, then that C is a critical point. Let's solve a problem. then you understand this well. He said, I have f of x is equal to 3x squared minus 12x plus 5 on the interval 0, 3. How do I find my absolute minimum and maximum values? What you're going to do is, if I have this curve, I have something we call the endpoint here, or the intervals with which the function is defined on. So a function can have its peak at the edge. A typical example is this. You can have something like this, and here will be A, here will be B. So you can have the peak of the function at the endpoint. We can also have the peak in the interval. So what you're going to do is, the first thing you do is to put your peaks and find their corresponding y value. And you find your critical point, you put it back into the function, you find the y value. Then the greatest of all will be the maximum, and the smallest will be the absolute minimum. So let's go ahead and put 0. F of 0 is simply 3 open bracket 0 minus 12 open bracket 0 plus 5. This is going to give me 5 because here will be 0, here will be 0. F of 3 is simply 3 multiplying 3 all squared minus 12 open bracket 3 plus 5. This should give me 3 squared 9, 27 minus 36 plus 5. This is going to give me negative 4 because I'm going to get 32 minus 36, which is equal to negative 4. Then I solve for my critical points. So f prime of x, which is my gradient function, will be 6x minus 12. 6x minus 12 should be equal to 0 to give me my critical point. Therefore, 6x will be equal to 12. X will then be equal to 2. So once I have x is equal to 2, I'll put it into my function as f of 2. What is f of 2? 3 open bracket 2 all squared minus 12 open bracket 2, then plus 5. This will give me 4. 12 minus 24 plus 5. 5 plus 12 is 17 minus 24 will give me negative 7. So I'm now having 5, negative 4, negative 7. I can then say that 5 is my greatest functional value here. Then I'll have negative 7 to be the least functional value here. So therefore, I will say that my function has the global minimum at x is equal to 2, or at the critical point, the function has the global minimum of negative 7. The functional value is negative 7, and the function will have it at s equals 2. Then when I come up here, you realize that the function will have its absolute maximum at the point s is equal to 0. S is equal to 0. So therefore, this is how we compare and we get the global or the absolute maximum or minimum, as well as the local minimum and maximum. From here, we can say that negative 4 is a local minimum. Yes, it's not above everything. Thank you for joining this class. We go again. See you in the next class. Don't forget to like, subscribe, and also share.